Hello dear students, in this video I'll solve the sample paper 3 from Oswaal's sample paper series for term 2. So first we have section A, which is of 2 marks each. The first one, evaluate integral 0 to 1 e raised to x square x dx. So first let us write, let I is equal to integral 0 to 1 e raised to x square x dx. We can use integration by substitution. So let us put x square equal to t, so that we get 2x dx is equal to dt, or x dx is half dt. Therefore, and we should also change the limits. When x is equal to 0, t is equal to 0, x is equal to 1, t is also equal to 1. Therefore, I is equal to integral 0 to 1 e raised to t into dt by 2. So we get I is equal to half of integral e raised to t dt is e raised to t with the limits 0 to 1. So it is half into e raised to 1 minus e raised to 0, or it is half of e minus 1. So this is the value of the given definite integral. Moving on to the next question. Find the area of the region bounded by the curve x is equal to 2y plus 3, y-axis, and the lines y equal to 1 and y equal to minus 1. So if we draw a rough diagram for this, so this is the line x is equal to 2y plus 3. This is x is equal to 2y plus 3. Then y is equal to 1 is a straight line passing through the it is a straight line which passes through 0, 1 and parallel to the x-axis. This is y is equal to 1 and this is y is equal to minus 1. This is the x-axis and this is the y-axis. So the region bounded by this curve, the lines y equal to 1 and y equal to minus 1 is this part. So the required area is the area of the shaded region. So required area equal to area of the shaded region. This is minus 1 and this is 1. So it is integral minus 1 to 1 f of y dy. So we have to find the area of this region. It is integral minus 1 to 1. This curve 2y plus 3 dy. So it is integral minus 1 to 1 2y plus 3 dy. Now this is very easy. We know how to integrate this. If we integrate and substitute the limits, we will get the answer. So it is y square plus 3y from the limits minus 1 to 1. So it is 1 plus 3 minus 1. Minus of minus 3 is plus 3. So the required area is 3 plus 3 equal to 6 square units. So this is the R part in the first question. It carries 2 marks. Moving on to the next question. A machine costing rupees 50,000 has a useful life of 4 years. If the estimated scrap value is rupees 10,000, then find the annual depreciation. So here the cost of the machine is given and the scrap value is given. Useful life is also given. We need to find the annual depreciation. So given cost of the machine C is rupees 50,000. Scrap value S is rupees 10,000. And the useful life N is 4 years. Annual depreciation D is given by C minus S upon N. So it is 50,000 minus 10,000 upon 4, which is 40,000 by 4. It is equal to rupees 10,000. So this is the annual depreciation. Moving on to the next question. What is the sum of money needed now so as to get rupees 6,000 at the beginning of every month forever when the money is worth 6% per annum compounded monthly? So we need to find the sum of money that we have to invest now so that we will get rupees 6,000 at the beginning of every month forever. So it is nothing but present value of perpetuity. So first let us write what is given. Given R is rupees 6,000, then I is 6% per annum compounded monthly. So it is 6% upon 12. It is 0.06 by 12 or it is 0.005. We know the formula for present value of perpetuity when the payments are done at the beginning of every period. So it is given by R plus R by I. R is 6,000 plus 6,000 upon 0.005. So this is equal to 6,000 plus 6,000 upon 0.005 is 12 lakhs. So it is 12 lakhs 6,000. Therefore, required sum is rupees 12 lakh 6,000. So if 12 lakh 6,000 is invested now, we will get rupees 6,000 at the beginning of every month forever when money is worth 6% per annum compounded monthly. Moving on to the next question. Assume that Shyam holds a perpetual bond that generates an annual payment of rupees 500 each year. He believes that the borrower is creditworthy and that an 8% interest rate will be suitable for this bond. Find the present value of this perpetuity. So here annual payment is made each year. So this is R and the interest rate is 8%. This is I. It is a perpetual bond. So again we need to find present value of perpetuity. Given R is rupees 500, I is 8%. It is 0.08. So the present value of perpetuity, it is given by R by I, which is 500 by 0.08. It is equal to rupees 6,250. Moving on to the next question. A wholesaler in apples claimed that only 4% of the apples supplied by him are defective. A random sample of 600 apples contains 36 defective apples. Calculate the standard error concerning good apples. So here the population proportion is given. We need to find the standard error of the sample proportion. So first let us write what is given. Population proportion P is, it is claimed that 4% of the apples are defective. So P is 4% or it is 0.04. Then we have studied Q as 1 minus P. It is 1 minus 0.04, which is 0.96. Now the sample proportion will be, out of 600 apples that we had 36 defective apples. So sample proportion is 36 upon 600. It is 0.06. Now the standard error of sample proportion, it is given by root of PQ by N. N is given as 600. So P is 0.04, Q is 0.96 and N is 600. So this, when we simplify, we get it as root of 0.0384 upon 600, or standard error is equal to root of 0.000064. So this is 0.008. So the standard error of sample proportion is 0.008. Moving on to the next question. It is given, calculate 3 yearly moving averages of number of students studying in a higher secondary school in a particular village from the following data. So for various years, the number of students are given. We need to find the 3-yearly moving average. So let us draw a table like this. For various years, the number of students data which is given in the question is written here. Then we have to find 3-year moving total and 3-year moving average. 3-year moving total is, for 2012, it is the sum of these three. We will not have the first year. If we add these three, 332, 317, 357, we get 1006. Then 317, 357, 392, 1066. Then 357, 392, 402. It is 1151. Alongside, we can calculate the 3-year moving average also. 3-year moving total for the first 3 years, it is 1006. 3-year moving average will be 1006 divided by 3. It is 335.33. Then for the year 2013, the 3-year moving total is 1066. 3-year moving average will be 1066 by 3, 355.33. Then the next 3-year moving total is 1151. 3-year moving average will be this divided by 3, 383.67. Now the next 3-year moving total for 2015, it is 392, 402, 405. The sum of these three, it comes out to be 1199. Divided by 3, 399.67. Then for 2016, it is the sum of these three. It is 1217 divided by 3, 405.67. Then for 2017, the 3-year moving total is 405, 410, 427. The sum of these three, it is 1242 divided by 3. It is 414. For 2018, the 3-year moving total is 410, 427, 435. The sum of these three, it is 1272. 3-year moving average is divided by 3. It is 424. And then we have for 2019, the 3-year moving total is 427, 435, 438. The sum of these three, it is 1300 divided by 3 is 433.33. So these are the 3-year moving total and 3-year moving average. Finding 3-year moving total carries 1 mark and 3-year moving average carries 1 mark. Moving on to the next question. Draw the feasible region for the given inequation system. Y less than or equal to 6, x plus y less than or equal to 2, x greater than or equal to 0 and y greater than or equal to 0. First we have y less than or equal to 6. Y less than or equal to 6, x plus y less than or equal to 3, x greater than or equal to 0 and y greater than or equal to 0. So let us draw the x-axis and the y-axis. Here y less than or equal to 6. First let us draw the line y equal to 6. Y equal to 6 is a straight line which passes through 0, 6 and parallel to the x-axis. So this is y equal to 6. And next we have x plus y equal to 3, the next line. So let us draw a table like this. When x is 0, y is 3, and when y is 0, x is 3. So let us plot the points 0, 3. This is 0, 3 and 3, 0. If we draw a line joining these 2 points, we will get the line x plus y equal to 3. Now y less than or equal to 6. It is this part. Then x plus y less than or equal to 3. If we substitute the origin and check 0, 0, we get 0 less than 3. So it is this part. So the feasible, next we have x greater than or equal to 0, y greater than or equal to 0 is the first quadrant. So the region which is common to all these inequalities is this triangle. If we mark this point as P and this point as Q, the feasible region corresponds to OPQ. So this is the feasible region. So feasible region is OPQ. Moving on to the next question. Find the producer surplus defined by the supply curve S of x is equal to 4x plus 8 for the supply of 5 units. So here x naught is given. We need to find the producer surplus when x naught is 5 units for this supply curve 4x plus 8. So we have the supply curve given by P is equal to 4x plus 8. Substituting x naught is equal to 5 in P equal to 4x plus 8. We get P naught is equal to 4 into 5 plus 8, which is 28. Now the producer surplus is given by P naught x naught minus integral 0 to x naught g of x dx. So P naught is 28 and x naught is 5 minus integral 0 to 5. Supply curve is given by 4x plus 8 into dx. So this is 140 minus 4x square by 2 plus 8x with the limits 0 to 5. Now when we substitute the upper limit, we get 25 into 2, 50, then 8 into 5, 40, and lower limit is 0. So this is 140 minus 90, which is 50. So the producer surplus is given by rupees 50. Moving on to the next question. Given below are the data relating to the sales of a product in a district. Fit a straight line trend by the method of least squares and tabulate the trend values. So for various years, the sales data is given. We have to fit a straight line trend using the method of least squares. So let us draw a table like this. We have year and the sales for various years given here. The sales is represented by Y. And now let us have x as year minus, here let us count the number of years. The number of years is 2, 4, 6, 8. It is even. So we have x as year minus the average of these two. That is 2018.5 upon 0.5. So what happens is for 2018, we will have the value of x as 2018 minus 2018.5 by 0.5. This is minus 1. For 2019, it will be 1. Then for 2017, x value will be minus 3. For 2020, it will be plus 3. 2016 minus 5. 2021 plus 5. 2015 minus 7. 2022 plus 7. So that we get summation x as 0. Here summation y, when we add all these, we get 47.8. And then we need to have xy and x square. Xy is product of these two. So when we multiply x and y, we get minus 46.9, then minus 26.5, then minus 12.9, minus 6.1, 5.6, then 23.7, then 29.0, then 42.7. So summation xy will be, here if we add all the positive terms we get 101 and all the negative terms comes out to be 92.4. So it is 8.6. Next we have x square. X square minus 7 whole square 49, minus 5 whole square 25, minus 3 whole square 9, 1, 1, 9, 25, 49. Now summation x square is equal to 168. Now we have a is equal to summation y by n. Summation y is 47.8 upon n is 8. So this when we simplify we get 5.975. And then b is summation xy upon summation x square. Summation xy is 8.6 and summation x square is 168. So this when we simplify we get 0.0512. So we got the trend line. Therefore, trend line is yt is equal to a plus bx, which is 5.975 plus 0.0512x. Now we can find the trend values. Yt is equal to 5.975 plus 0.0512x. So for the year 2015, we have to substitute x as minus 7 and find the value of the trend line. Yt is equal to 5.975 plus 0.0512x. So it is 5.975 minus 7 into 0.0512. When we simplify, we get 5.62. Then for 2016, 5.975 minus 0.0512 into minus 5. So it is 5.72. And then 5.975 minus 3 into 0.0512. It is 5.82. Here I have rounded off to two decimal places. If we proceed like that, we get 5.92, then 5.975 plus 0.0512. When we round off, we get 6.02. Then 5.975 plus 0.0512 into 3, 6.13. Then 5.975 plus 0.0512 into 5, 6.23. Next 5.975 plus 0.0512 into 7. It is 6.33. So these are the trend values for all these years and this is the trend line. Moving on to the next question. From the following data, calculate 4 yearly moving averages and determine the trend values. So here we need to find the 4 yearly moving averages. So let us draw a table like this. We have to find 4-year moving total, then 4-year moving average and 4-year centered average. Finding 4-year moving total carries 1.5 marks and 4-year centered average carries 1.5 marks. 4-year moving total is the sum of the first 4 years values, which should be written in between the second year and the third year. 50, 36.5, 43 and 44.5. All these add up to 174. Here 4-year moving average is 174 divided by 4. It is 43.5. Next 4-year moving total is sum of these 4 values. It is 162.9 and 4-year moving average is 40.725. Next 4-year moving total is 43, 44.5, 38.9, 38.9. It is 165.3. 4-year moving average is divided by 4. It is 41.325. Next 4-year moving total is the sum of these 4 values. All these add up to 154.9 divided by 4, 38.725. Then the next Fourier moving total is 38.9, 38.9, 32.6, 41.7. It is 152.1. The Fourier moving average is 38.025. Next Fourier moving total is the sum of these four values. It is 154.3. And divided by 4 it is 38.575. Next Fourier moving total is the sum of the last four values. It is 149.2. Divided by 2, 149.2 divided by 2, it is 37.3. Now the Fourier centered average, it is the average of these two values, so that we will get the trend values along each year. Here we are getting the Fourier moving average between 2 years. We need the trend values along each year, so we find Fourier centered average. So here the average of these two, 43.5 plus 40.725 divided by 2, it is 42.1125. Next we have 40.725 plus 41.325, which is 80.050 divided by 2, 40.025, 41.025. Next we have the average of these two, 41.325 plus 38.725 divided by 2. It is 40.025. Next we have 38.725 plus 38.025 divided by 2. 38.375. Next we have the average of these two. It is 38.3. And finally the average of these two, 38.575 plus 37.3 divided by 2, 75.875 by 2, it is 37.9375. So these are the Fourier's centered average and Fourier's moving average, Fourier's moving total. Moving on to the next question. 10 individuals are chosen at random from the population and their heights are found to be in inches. These are the heights given for the 10 individuals. Discuss the freedom value of student's height and 5% level of significance is 2.62 if mean height of the universe is 65 inches. So here they have given the mean height of the universe is 65 inches. It means population mean is 65. We need to find whether the mean of the sample is significant or not. So let us first define null hypothesis H0 and alternate hypothesis H1 as follows. So H0 is mu equal to 65 inches and alternate hypothesis H1 is mu not equal to 65 inches. So we have a two-tailed test which is applied under H0 and we have the test statistic T as x bar minus mu upon S by root 10, or it is x bar minus mu upon S into root 10. Now let us find x bar, S, all these. So let us draw a table like this. We have xi. Here summation xi is, when we add all these values, we get 670. So summation xi is 670. X bar is equal to summation xi by n. It is 670 by 10, which is 67. Since we are having an integer, we need not use assumed mean. So let us take xi minus x bar directly. So xi minus x bar will be 63 minus 67 minus 4, again 63 minus 67 minus 4, 64 minus 67 minus 3, 65 minus 67 minus 2, 66 minus 67 minus 1, 69 minus 67 2, 2, 70 minus 67 3, and 71 minus 67 is 4. So this, when all these add up to 0. Next we have xi minus x bar the whole square. The reason for doing all this is we have s as root of summation xi minus x bar the whole square upon n minus 1. So this is the, where s square is the unbiased estimator of population variance. So the square of all these is 16, 16, 9, 4, 1, 4, 4, 9, 9, 16. When we add all these, we get 88. Now we can find yes. So this is root of 88 upon 10 minus 1. So this is root 88 upon root 9. So it is root 88 by 3. Now let us find the square root of 88. So let us find up to 2 decimal places. We have 9 nines are 81, 7. Bring the next pair of digits. Here we have 9 plus 9, 18. Let us place a decimal point here. Let us try 183 into 3. So we get 549. Let us bring the next pair of digits. Here we have 186. Let us try 8. So when we have 1868 into 8, it is so this, when we subtract, we get 156. So root 88 is 9.38. So it is 9.38 divided by 3, or it is 3.13. So we got S as 3.13. Now we can find T. T is equal to 67 minus 65 upon 3.13 into root 10. So it is 2 by 3.13. We are familiar with the value of root 10. Value of root 10 is 3.16. Now this, when we simplify, we get it as 2.03. So we got the calculated value of T as 2.03. At 5% level of significance and 9 degrees of freedom, the table value of T is 2.62. But since this value is less than 2.62, it means we can accept H0. Since T equal to 2.03 lies in the interval minus 2.62 to 2.62 for 10 minus 1 equal to 9 degrees of freedom, we accept H0. So if we have, it is a two-tailed test. So this is minus 2.62 and this is plus 2.62. This is the rejection region and this is the acceptance region. If we see this value 2.03, it lies in this acceptance region. So we accept H0. And we conclude that therefore mu equal to 65 inches. We conclude that the mean height of the universe is 65 inches. Moving on to the next question. A company ABC Limited has raised funds in the form of 1000 zero coupon bonds worth rupees 1000 each. The company wants to set up a sinking fund for repayment of the bonds, which will be after 10 years. Determine the amount of periodic contribution if the annualized rate of interest is 5% and the contribution will be done half yearly. So we need to find the amount in the sinking fund should be 1000 into 1000. Since it is a zero coupon bond, it means it is redeemed at par. So the amount in the sinking fund should be 1000 into 1000, which is 10 lakhs, and the time period is 10 years, annualized rate of interest is 5%, and contribution is done half yearly. So the amount of sinking fund A at any time, it is given by A is equal to R into 1 plus I the whole raised to n minus 1 upon I, where R is the periodic payment, I is the interest per period, and n is the number of payments. Here we have A as 1000 into 1000. The amount in the sinking fund should be 1000 into 1000, which is rupees 10 lakhs. And then the interest per period I is 5%, and it is done half yearly. So 5% by 2, which is 0.025. And the number of payments will be, it is 10 years and contribution is done half yearly. So number of payments will be 10 into 2, 20. So if we substitute all these, we get 10 lakhs equal to R into 1 plus 0.025 the whole raised to 20 minus 1 upon 0.025. So here 10 lakh into 0.025, 25,000 equal to R into 1.025 the whole raised to 20 is given as 1.6386. 1.6386 minus 1. So from this we get R as 25,000 upon 1.6386 minus 1 is 0.6386. 0.6386. So this, when we simplify, we get it as rupees 39,148.14. So this is the amount of periodic contribution. The amount of periodic contribution is 39,148.4. Formula carries 1 mark. Substituting all the values carries half mark. Remaining steps and the final answer carries 1.5 marks. Moving on to the next question. A farmer has a supply of chemical fertilizer of type A which contains 10% nitrogen and 6% phosphoric acid, and of type B which contains 5% nitrogen and 10% phosphoric acid. After soil test, it is found that at least 7 kg of nitrogen and same kg of phosphoric acid is required for a good crop. The fertilizer of type A costs rupees 5 per kg and type B costs rupees 8 per kg. Using linear programming, find how many kilograms of each type of fertilizer should be bought to meet the requirement and for the cost to be minimum. Find the feasible region in the graph. So here it is given. First let us draw a table so that it will be easy for us to understand. So we have two types of fertilizers, type A and type B, and the nutrients are nitrogen and phosphoric acid. It is given the fertilizer of type A contains 10% nitrogen and 6% phosphoric acid. 10% nitrogen and 6% phosphoric acid. Type B contains 5% nitrogen and 10% phosphoric acid. 5% nitrogen and 10% phosphoric acid. After soil test, it was found that at least 7 kg of nitrogen and same quantity of phosphoric acid is required for a good crop. So minimum requirement of nitrogen is 7 kg and phosphoric acid is also 7 kg. Here fertilizer of type A costs rupees 5 per kg. So this costs rupees 5 and type B costs rupees 8 per kg. Type B costs rupees 8. We need to formulate this as an LPP and find the feasible solution. So let us take, let x kg of type A and y kg of type B fertilizer be bought to meet the requirement. So we have the objective function is minimize z is equal to, we have taken x as type A and y as type B. So minimize z is equal to 5x plus 8y. 5x plus 8y subject to the constraints the first constraint is 10% of x plus 5% of y. It should be greater than or equal to 7. So 10 by 100 x plus 5 by 100 y greater than or equal to 7. We do it in 5. So we get 2x plus y greater than or equal to 140. Then the next constraint is 6% of x plus 10% of y greater than or equal to 7. 6 by 100 x plus 10 by 100 y greater than or equal to 7. 3x plus 5y greater than or equal to 350. And next we have the non-negative constraints. Here we cannot buy a negative amount of fertilizer. So x greater than or equal to 0 and y greater than or equal to 0. So these are the constraints. This is 1, this is 2 and the non-negative constraints. Now let us find the feasible region and the solution. So we got the constraints as 2x plus y greater than or equal to 140 and 3x plus 5y greater than or equal to 350. Let us take this as 1, this as 2. So for 1, when x is 0, y is 140. When y is 0, x is 70. So let us take a graph sheet, mark the x-axis, y-axis. Let us take the units as 20, 40, 60, 80, 100, 120, 140, 160. Same here. Now we have 0, 140, it is this point, and 70, 0. So if we draw a straight line joining these 2 points, we get the line 2x plus y equal to 140. So this is the line corresponding to the first equation. Next we have 3x plus 5y greater than or equal to 350. So for the second one, all these can be done in rough. When x is 0, y is 70, and when y is 0, x is 350 by 3. So 0, 70 is somewhere here and 350 by 3 is somewhere here. So if we draw a straight line joining these 2 points, we get the second equation. Now here 2x plus y greater than or equal to 140, it is this part. And 3x plus 5y greater than or equal to 350 is this part. Because the origin does not lie in this plane, so it is the other side. and x greater than or equal to 0, y greater than or equal to 0 is the first quadrant. So the feasible region is this region. So this is the feasible region. And we have these corner points. This is one corner point P 0, 140. This is Q and this is R 350 by 3, 0. So the corner points are P 0, 140. The coordinates for Q, if we solve these two equations, we will get the coordinates for Q, or even from the graph, we can get the coordinates for Q. Here if we see the graph, the y coordinate is 40. If we substitute y as 40 in 1, we get 2x is equal to 100, so x is 50. So the coordinates for Q is 50, 40. Q is 50, 40. And R is 350 by 3, 0. Now let us find the value of z at these three corner points. So when x is 0 and y is 140, z is 8 into 140. It is 1120. Next, when x is 50 and y is 40, 50 into 5, 250 plus 320. It is 570. Next, when x is 350 by 3 and y is 0, we get 1750 by 3, or it is 583.33. So this is the minimum value. So the minimum value of z is 570 for q 50, 0. And now since this feasible region is unbounded, we have to check the half plane corresponding to z less than the minimum value. That is 5x plus 8y less than 570. So we have to check this. So one point is this q 50, 40, that is one point. Another point is if we substitute y as 0, we get x as 114. It is somewhere here. So if we draw a line joining these two, it is this line which corresponds to 5x plus y equal to 570. Now 5x plus 8y less than 570. It is this part. So it is this part. So here we can see that 5x plus 8y less than 570, it passes through this corner point Q and does not interfere or cross the feasible region. So the minimum value of z is 570 and it occurs at Q 50, 40. So the smallest value of z is 570. Since the feasible region is unbounded, we draw the graph 5x plus 8y less than 570. As the inequality 5x plus 8y less than 570 passes through the corner point Q and does not cross the feasible region. It means this particular linear programming problem has got a unique solution. The minimum cost is rupees 570 when 50 kg of type A and 40 kg of type B fertilizers are used. So if 50 kg of type A fertilizer and 40 kg of type B fertilizer are used, the cost will be minimum and the minimum value is rupees 570. So here formulating the given linear programming problem, it carries 1.5 marks. Drawing the graph carries 1.5 marks. Then the corner point and writing the result, all these carries 1 mark. So a total of 4 marks. Moving on to the next question. Find the value of a rupees 1000 corporate bond with an annual interest rate of 5%, making semi-annual interest payments for 2 years, after which the bond matures and the principal must be repaid. Assume an yield to maturity of 3%. So here the face value of the bond is given, annual interest rate is given, and payments are made semi-annually for 2 years. So the bond matures after 2 years. And yield to maturity is also given. We need to find the value of this bond. First, let us write what is given. So here it is given. The face value of the bond F is rupees 1000. And then since nothing is said about the redemption price, we assume that the bond is redeemed at par. So the redemption value is again rupees 1000. And then the nominal rate or coupon rate, it is given as interest rate, annual interest rate is 5%, but since semi-annual interest payments are made, the nominal interest rate ID will be 5% upon 2, or it is 0.05 by 2, which is 0.025. Next, we have the periodic dividend payment R. It is given by face value of the bond into the nominal rate. So it is 1000 into 0.025, which is 25. So R is rupees 25. And then we have number of periods before redemption. Here interest payments are made for 2 years, after which the bond matures. It means the bond is redeemed after 2 years. And since semi-annual payments are made, number of periods before redemption will be 2 into 2, which is 4. And next we have the yield rate. Here they have given yield to maturity is, it is 3%. So they have given the yield rate directly. So we have I is 3% or it is 0.03. Now we have to find the value of this bond. So we can use the formula purchase price or value of the bond, fair value of bond. P is equal to R into 1 minus 1 plus I the whole raised to minus n upon I plus C into 1 plus I the whole raised to minus n. So here R we have got it as 25 into 1 minus 1 plus I is 0.03, the whole raised to minus n is 4 upon 0.03 plus C is 1000 into 1 plus 0.03 the whole raised to minus 4. Here it is given 1.03 the whole raised to minus 4 is 0.8885. So 25 upon 0.03 is 833.33 into 1 minus 1.03 the whole raised to minus 4 is 0.8885. 0.8885 plus 1000 into 0.8885. So this is 833 into 833.33 into 0.1115 plus 888.5. Now this when we multiply we get 92.92 plus 888.5 or it is equal to 981.45. Therefore, value of the bond V is equal to rupees 981.42. So writing what is given, then finding the nominal interest rate, periodic dividend payment, number of periods before redemption, all these carries 1.5 marks. Then writing the formula for purchase price or fair value of the bond, substituting the values and all these calculations carries 1.5 marks. And the final answer, writing the final answer carries 1 mark. So a total of 4 marks for this question. A machine costs rupees 97,000 and its effective life is estimated to be 12 years. If scrap realizes rupees 2,000 only, what amount should be retained out of profits at the end of each year to accumulate at compound interest of 5% per annum in order to buy a new machine after 12 years? So here the cost of the machine is given, its effective life is given, and scrap value is given. We need to find the amount that we have to retain out of profits to accumulate at an interest of 5% per annum in order to buy a new machine after 12 years. So this is also sinking fund question. The amount of sinking fund A at any time is given by A is equal to R into 1 plus I the whole raised to N minus 1 upon I, where R is periodic payment, I is interest per period, and N is the number of payments. Now we have A as 97,000 minus 2,000. So it is 95,000. So the sum accumulated should be 95,000. And then I is 5% or it is 0.05. N is 12 years. So this implies 95,000 equal to R into 1 plus 0.05 the whole raised to 12 minus 1 upon 0.05. So here 95,000 into 0.05, it is 4,750. This is equal to R into 1.05 the whole raised to 12 minus 1. This 1.05 the whole raised to 12 is given as 1.769. So we get 4,750 equal to R into 0.769. So we get R as 4,750 upon 0.769. Just when we simplify, we get it as 6,176.85. Therefore, R is rupees 6,176.85. So the amount that should be retained out of profit at the end of each year, it is rupees 6,176.85. So here writing the formula carries 1 mark, and then substituting the values, all these carries 1.5 marks, and then finding the value of R, the remaining steps carries 1.5 marks. Last question, we have the case study question. Mr. Lal was 75-year-old businessman. He had 2 sons and 3 daughters. On the silver jubilee of his company, he gifted an equal amount of money among his children. One of his daughters buys jewelry from the gifted money, whereas the other daughter invested her money in bank. It is known that if the interest is compounded continuously, the principal changes at the rate equal to the product of rate of bank interest per annum and principal. If P denotes the principal at time t and rate of interest be R% per annum compounded continuously, then find the differential equation that models this scenario. Also find the particular solution of the differential equation. At what rate of interest will rupees 100 double itself in 10 years? Now this question is on mathematical modeling using differential equation, where we have to find the differential equation for when money is compounded continuously. So we will do each subdivision one by one. If P denotes the principal at time t and rate of interest be R% per annum, we have to find the differential equation that models this scenario. So here it is given, if the interest is compounded continuously, then principal changes at the rate equal to the product of rate of interest and principal. So here it is given dp by dt, it is equal to P into R. This is what is given. So using this, let us find the differential equation and the solution. So first subdivision, given dp by dt is equal to p into r. So from this we get dp by p is equal to r into dt. Integrating both sides. So we get integral dp by p equal to integral r dt. Or we get log p is equal to rt plus c. This is log p to the base e. So we get p is equal to e raised to rt plus c. Or p is equal to e raised to rt into e raised to c. Or let us take this is equal to k into e raised to rt. When t equal to 0, that is initially we have p equal to p naught. So from this we get p naught is equal to k. Therefore, p is equal to p naught into e raised to rt. So this is the mathematical model. Now moving on to the second subdivision. At what rate of interest will ₹1000 double itself in 10 years? So in the second subdivision, given P naught is ₹100, we need to find the rate of interest at which ₹100 will double itself. That is, P becomes 2 times P naught. So P is ₹200 and T is 10 years. Let us take this as 1. From 1, 200 is equal to 100 into e raised to 10 r. So we get 2 is equal to e raised to 10 r. If we take log on both sides, we get log 2 is equal to, it is 10 r log e. Log e to the base e is 1. This is 1. And log 2 to the base e, it is given in the question 0.6931. This implies 0.6931 equal to 10 r. Or r is 0.6931 upon 10. It is 0.06931. Therefore, r is equal to 6.931%. So the rate of interest at which ₹100 will double itself in 10 years is 6.931%. Here finding what is given and finding up to this step. Log p, it carries 1 mark. Then getting the differential equation, getting the solution of the differential equation carries 1 mark. And then the next subdivision, it carries 2 marks. I hope this video was useful for you. Thank you for watching.